Assalamu alaikum. I hope that you are all fine. In this part, we are going to study the RC circuit in the case of discharging of a capacitor. After studying the charging process of an RC circuit, now we are going to study the discharging process in an RC circuit. As you can see that in this circuit we have a resistor and a capacitor which are connected in parallel. You can see here that the capacitor has a maximum voltage of 10 volts and it has two plates. One is negatively charged of charge minus Q and the other one is positively charged of charge plus Q. When I close the switch, then the discharging process will start where the capacitor discharges in the resistor. We are going here in this animation to see the variation of Q as a function of t and the variation of I as a function of t. Notice here that both graphs are decreasing exponentially because they are faster at the beginning and slower at the end. For example, I decreases from the maximum value, which is I0, until it reaches the value which is equal to 0 at the end of the discharging process, and at time t is equal to tau, as you can see in this figure or in this graph, the value of the current is 0.36 from I0, or we can say that the current loses 63% of its maximum value, then the remaining value is 37% or approximately 0.368. Here in this animation there is no graph showing the variation of U as a function of t, but the variation of U as a function of t is very similar to I and it is very similar to Q. It is a decreasing function, decreasing exponentially, and it is starting from U maximum, which is the maximum voltage of the capacitor, reaching 0 at the end of the discharging process. Let us now define tau for the discharging process. We know that at time t is equal to tau, the capacitor discharges 63% of its maximum voltage. Then UC, which is the voltage of the capacitor at time t is equal to tau, is equal to E minus 0.63E, which is equal to 0.37E. Then the voltage remaining in the capacitor at time t is equal to tau is equal to 0.37E, or it is equal to 37% of the maximum voltage of the capacitor. At time t is equal to 5 tau, where the capacitor is practically fully discharged, the capacitor discharges 99% of its maximum voltage, then UC is equal to E minus 0.99E, which is approximately equal to 0. At time t is equal to tau, the current in the circuit loses 63% of its maximum value, then the value of the current is I is equal to I0 minus 0.63 I0, which is equal to 0.37 I0. Then at time t is equal to tau, the current circulating in the circuit will be equal to 0.37 I0. At time t is equal to 5 tau, where the capacitor is practically fully discharged, the current in the circuit is approximately 0, then I is equal to 0. Application number 5. A capacitor of capacitance C has an initial charge Q0, is branched across the terminals of a resistor R is equal to 5 kilo ohm. At time t is equal to 0, K is closed. Figure B shows the voltage of the capacitor as a function of time. This is the figure which shows the variation of UC as a function of time, and this is the circuit showing the capacitor and the resistor. Part 1. Name the phase of the capacitor. The phase is discharging. Part 2. Indicate the direction of the electric current in figure A. The direction of the current will be from the positive plate of the capacitor towards the negative plate. Answer the following questions using, if possible, figure B. This figure. Pick out at time t equal to 0 the voltage of the capacitor. What is the voltage of the capacitor at time t equal to 0? From the graph, it is equal to 12 volts, which is equal to E, the EMF of the battery. Part B. Determine the constant of the circuit, RC circuit, reduce C and Q0. What do we mean by the constant of the circuit? We mean tau, and we know that at time t is equal to tau, the abscissa of the ordinate UC is equal to 0.37 times E. Then, I have to calculate this value, which is equal to 0.37 multiplied by 12 is equal to 4.44 volts. Then I have to go to the graph and look to the point. Having an ordinate 4.44, this point has an absolute tau which is equal to tau and it is equal to 1 second. How do we deduce C? We have to say that C is equal to tau divided by R, which is equal to 2 times 10 to the power minus 4. Q0 is equal to C times U0C, which is equal to 2.4 times 10 to the power minus 3. Calculate at time t equal to 0 the electric energy stored in the capacitor. I have to use the formula W0 is equal to half CU0 squared, which is equal to, by calculation, 0.0144 joules. Here, U0 should be equal to 12, and the capacitance C is given, or we have calculated in part B. The last part, I have to calculate at time t is equal to 0.5 seconds, the current I in the circuit, the electric energy stored in the capacitor, and the energy dissipated in R by Joule's effect. We all know that the resistor transforms the energy from electric energy into heat energy, or Joule's effect. That's by Joule's effect. We have to find the quantity of this energy which is dissipated in the resistor. UAB is equal to UC. That's because according to the law of parallel connections, the voltage is equal. Then UAB, which is the voltage of the capacitor, is equal to UC, and UAB is equal to R times I. Then UC is equal to R times I, therefore I is equal to UC divided by R, which is equal to 2.4 times 10 to the power minus 3 amperes. Now, how do we calculate the energy dissipated in R by Joule's effect? This is done by two steps. First of all, we are going to calculate the energy which is stored in the capacitor at time t is equal to 0.5 seconds, as if we are calculating the energy remaining in the capacitor at this instant, and this is calculated using the following formula, half t squared, and it will give 6.4 times 10 to the power minus 3 joules. So till now we've calculated the energy which is stored in the capacitor at time t is equal to 0. But in order to find the energy dissipated in R by Joule's effect, or in other words, in order to find the energy which is given by the capacitor to the resistor, then I have to subtract the total energy stored in the capacitor initially minus the remaining energy which is stored in the capacitor at time t equal to 0, and this will give the energy which is given to the resistor by the capacitor, and it will give 8 times 10 to the power minus 3 joules. I hope that you've understood all what we've explained in this video. Study them very well. Thank you.